Hello, welcome everyone. I'm Christopher Porter, representing Google today, talking about APT threats to AI systems. An important subject. I know we had a lot of interest in this going into it. Before I go into the substance of what I'm here to share today on those threats, I want to share just a little bit about, how is it that we even know any of what we're talking about, right? How do I know about these APT groups? What is the source of our intelligence? This is a marketing kind of slide that I stole from a colleague at Google. It talks about how many users we have and how big our pipes are. So, if you imagine all of these products and services, these are also potential sources of intelligence for me on the threats that we face. So, you can see here we've got 5 billion users. This is any kind of Chromium based browser, so Chrome or Edge or something like that. If you hit a malicious domain, we're going to hopefully pick that up. And as soon as any of our users picks it up, it pretty quickly propagates to protect all of our other users. We've got billions of Gmail users. So if an APT group is spearphishing or targeting a Gmail user, or conversely, using a Gmail account to, attempt to spearphish or send malware to others, that's two different ways we might have of knowing about that operation. Virus Total, this is an enormous database of malware, but also malicious URLs. This is sourced not just from us, but from many leading security firms, antivirus vendors. Working at Google, we have the same, access to information that you can get commercially. There's nothing different about our data set, but obviously we have access to it and we can run queries against it at large scale. You start talking about if you're operating in the cloud, we can't see inside your cloud instance by design, but we might see outbound traffic, or if a customer who's working on Google Cloud has a problem, they might share some of the security information with us as well, logs or other things. We also, at any given point in time, control roughly 25% of the internet. That could be fiber optic cables, that could be server kind of elements, but 25% of data in motion on the internet at some point is running over infrastructure that we physically control. Not on this slide, but obviously now the concrete has hardened on our acquisition of Mandiant, a leading incident response firm. So we also have incident response data from typically sort of Fortune 2000 companies and major governments. Their customer set is going to tend to be very well defended, high end security, which means they're also picking up high end threats. The most sophisticated actors knew tactics and TTPs. So these are many different ways of knowing about a potential threat, different kinds of information. It's not just that we have more intelligence than others, it's that we have different types. So if you think about the way a magician does a trick, if you could see all angles of a magician's trick at the same time, there wouldn't really be much of a trick to it. They have to conceal something from the audience in order for their magic trick to work. Well, intelligence operations, cyber operations are much the same way. If you could see every element of what an operator who's on offense is doing, it'd be easy to stop and block and tell others about what they're doing. They have to conceal something from their target while interacting with them, who they are, how the software really works, where your password is going. Something has to be concealed. At Google, we have, not everything, but many different facets of a potential operation. We only have to catch one of them to expose the entire operation. So throughout the course of our discussion today, you'll see, I think, different kinds of knowledge and how we tap into that. First, let me talk about just briefly my background. I'm not an AI researcher, certainly not a Google quality AI researcher. My expertise is in the bad guys, the operators. How does one plan an offensive operation? And how do you catch that and expose that and analyze that? So AI for me is going to be discussed today through the lens of a tool. If I'm an intelligence agency or a military service or a criminal group, how do I accomplish my goals in part using AI? And that may be a little bit different from how an academic would think about it or a researcher trying to go to the cutting edge. But we're going to talk about what we actually see in real life. So one of the most useful things that generative AI in particular is useful for, this could be, Gemini, ChatGPT, any of those kind of LLMs. I know there's a lot of concern about those systems being used to create novel malware, and we'll talk a little bit about that today. Automated operations, which we'll also talk about. But the most immediate application, and actually one of the most dangerous, is as a translator. And I don't just mean literally translating from one language to another. I mean, that capability has been available on the internet for some time. But being able to mimic your target exactly, to not only speak their language, but to speak it with the right accent. Or if I have access to, an account on your system, but I really need this other person's account and their colleagues, being able to really impersonate the person who owns the account that I've compromised and use that to move laterally on a network, that's very powerful. There are some countries, Japan is a good example, where the language barrier has just prevented a lot of outside threats because it's hard to move laterally or to get the initial spearfish if you don't speak the language. Western countries, English-speaking countries, obviously can be vulnerable to groups from all over the world. I think what we're going to see is, and is already happening to some degree, as we'll discuss, but especially over the next year, some of those regional APT powerhouses like Iran, who are prolific actors in their region, And in Iran's case, they do target, Europe sometimes, and occasionally have gone after U.S. critical infrastructure or intelligence targets, but much less than they do in their own region. I think you'll see them being less constrained over time because of the ability to speak their target's language and to really blend in. The days of a spam or spear phishing email being obviously wrong because the cadence or the language, the word choice was wrong. That's long gone with these large language models. If I am a criminal operator and I want to sort of sell access to my own GPT, my own language model that I want my the other parts of sort of my international crime business to be able to use, and I can charge them cryptocurrency or other things for access to the system. Let's talk about what features the criminally available LLMs actually do. So, how are they doing this? In many cases, they are training or refining existing open source models. In some cases, they may be adding in some novel training of their own, but not anything at the scale that the major hyperscalers do. But these are systems that obviously some of the guardrails have been removed. Here, we mentioned the capabilities of several of these do vulnerability exploitation. That's not novel zero-day development. That is telling the GPT what systems you're looking at on your target and asking it what are the known vulnerabilities. So, sort of interrogating a Metasploit framework and finding the vulnerability that you need. You can also see malware development. I'll give a few examples of that. That is mostly obfuscation or code maintenance or updating. It's not yet at the point of developing truly concerning novel malware. A lot of overall research and reconnaissance, and a lot of help with spear phishing. So again, we can imagine how AI might be used in the future, theoretically, or 5 years from now. What's it being used for today? You really need to think immediately. Translator, helping me speak the language of my target and blend in. That's hiding a facet of my operation, blending in. So you see almost all of these criminally available LLMs offer phishing. Essentially, all of them almost offer technical support and code generation. So if you think about cyber criminals, they have international enterprises much like a legitimate enterprise. They cross country borders. They have different groups that specialize in different parts of the process, some that gain access, some that develop tools, some that speak maybe English really well or whatever the target language is. And once you've ransomwared them or you need somebody who can then talk to them on the phone and really pressure them and extort them at a personal level. There's different phases of a criminal operation, including back office. How do you do payroll? How do you do those kinds of mundane things? And so we actually see a lot of the GPTs being used for that, making the criminal business itself more efficient so that the limited pool of skilled hackers they have spend more of their time hacking or exploiting and so forth, and less of their time managing things. So they don't have to manage compromised accounts as much. They don't have to manage, ransomware victims, trying to automate as much of that as they can. Does that sound familiar to those of your organizations that are trying to think about how AI could be useful for you, right? You're focusing on your core competency and trying to take some of the other elements of it and automate it away. Believe it or not, that is largely what criminal LLMs are used for. When they sell AI to each other, they even use AI chatbots to offer tech support. So I mean, you got to think about it. This is a illegal generally, but this is a real business. If you're selling access to these kinds of systems, you have to have somebody who does tech support, somebody who helps when customers have complaints. They don't necessarily want to use human beings for that either. Not only does it cost money and maybe not scale as well, but obviously, if you're a criminal enterprise, that's an additional potential source of vulnerability for law enforcement penetration. So they are looking at using AI even to sell to one another. So again, as we're thinking about what is AI useful for, if I'm a bad guy and I'm on offense, I can use it for impersonating my victim. I can use it for automating some of my back office work. That is largely, overwhelmingly, what it's used for today and what they sell to each other business to business. What about the kinds of things that we see in the news, generating fake video and audio deep fakes? These are real threats. But this is a study that I believe DeepMind did, which is part of Google. This is a study they did on real world real operations we've actually seen that use generative AI. This is a little over a year ago, so it's a somewhat dated study. But at the time, if you notice, the number one thing that generative AI was used for was fake audio. Not fake video, as people often assume, because that's what we're familiar with from the news and from maybe social media, but fake audio. Well, again, think about how a ventriloquist works. Your mind is actually really good at detecting fake video, fake faces, even if it's sort of imperceptible and it looks flawless. You kind of at a gut level don't trust fake video. Fake audio actually really, really difficult for human beings to detect, even if the person speaking is well known to you. So imagine if you have a bad cellular connection. It could be somebody that you've, a spouse or another loved one who you've known for many years. You have a bad connection. You might say, well, who is this? Whereas if I put up a pixelated image of a celebrity, you would know right away who it was. So fake audio actually has a much lower barrier to entry in terms of success rate. And in fact, that is what we actually see being the most popular cyber criminal use of generative AI is for fake audio, not fake video. What are they using it for? Well, in the victims that we've monitored from among our customer set, it's concentrated in the finance sector. So, why do you rob a bank? Well, because that's where the money is. And so some of that is common sense. But actually, a lot of this that's not captured in this graph is those victims are concentrated in high net worth individuals. So, faking the audio of someone calling in to place a wire transfer or something like that. Many of the leading financial institutions have had to take new precautions on how do you verify customer identity. If whatever kind of business you're in, it could be you're dealing with customers and they're placing financial transactions, but it could be any sector. You need to understand that you now live in a world where someone could quite easily impersonate the phone number and voice of, for example, the CEO. So we do see wire transfer fraud that happens like that. Someone calls, accounting, and pretends to be a senior leader at the company and says, I'm sending you this invoice, or an important customer just complained we haven't paid this invoice. They order you to pay it. And if you're down there and the boss calls and says to pay this invoice and it comes to you electronically, even if it looks a little suspicious, that's just really hard to say no to. Likewise, in tech support, having someone pose as a senior leader, call up, sounds just like them, demand a password change, and so forth. So every sector, no matter what business you're in or government agency, needs to realize that relying on voice confirmation or even video confirmation for major decisions like that is no longer reliable. No one should be relying on that for major decisions. You should have, out of band means of verifying identity, or in person or other methods. So that's a longer discussion, but I would just suffice it to say, not only is this theoretically possible, but we actually see it all the time. I'm sure many of you are familiar with the North Korean IT workers. These are operations, real developers in North Korea getting remote work jobs and doing software development generally, or sometimes at cryptocurrency companies. Overwhelmingly, this is just something they do to make money. They can hold several of these jobs concurrently, and obviously the purchasing power parity is going to be much better in Pyongyang than in whatever country they're working remotely for. But some of these are also enablers of some software supply chain operations for North Korean intelligence. So there is both an immediate fraud aspect to it and the risk that you'll either be extorted if you catch them and fire them. They might try to release some sensitive company information, or just more directly, poison the software code, depending on what business you're in. So let's talk about what generative AI is theoretically useful for. This is another DeepMind study, more recent, looking at we took over 12,000 real cases from Google threat intelligence data from all of our customers, all of the threats to Google we've seen. And obviously, DeepMind, these are the world's best AI researchers, the sort of people who won, I think, 2 Nobel Prizes last year. So top thinkers. And we worked with them, and they took the data that we had and said, well, which parts of the offensive chain show the most promise for using AI to reduce the strain. What you'll see here in a general sense is that the better defined the operation is, the more guidance you could give an LLM. So SQL injection is a good example. It's a known technique, known exploitation. If you're scanning a target, it's either vulnerable or it's not, right? The reconnaissance on that is highly automatable. AI can definitely do it. Almost always they'll be able to attack it. Maybe some configuration edge cases where they don't succeed, but overwhelmingly they can. You start moving further down the line, down the chain there of that operation to exfiltrating data. There's more ambiguity, still very successful, but more ambiguity. Using a 0-day, developing a 0-day, even spear phishing, the translation part might go well, but the further down the chain you go to where you're trying to remove data from the target without yourself being detected, that's ambiguous. It requires a lot of judgment, and current AI systems show less capability there. So what does that mean? If you look at giving some of our leading LLMs different offensive security problems and ask them to solve them, the easy ones they can succeed at over half the time. The ones that are called strawman difficulty, meaning they're literally just definable textbook examples, no judgment whatsoever required. They just, it's you can follow a set of instructions and it will always work. 100% completion rate. Easy, 50%. Medium, you start talking about, I think that's around 15%, all the way down to 8% for the hard ones. And the most hard problems, we were not able to get an LLM to succeed at. So easy, well-defined kind of operations, AI shows a lot of promise. You could imagine cyber operators on offense doing this already. Maybe a hybrid of a human being on a keyboard with some agentic AI, doing the network reconnaissance, for example, finding the vulnerable exploited systems. But when it comes to risk taking, should I go after that target or not? Am I going to be detected or not? How do I deceive the defenders? Those more judgment oriented issues, at least at present, humans really would still need to do. Finally, let's go into just briefly what sort of choices are the leading APT groups actually doing? Nation state APTs overwhelmingly favor Gemini, ChatGPT, the other kind of leading commercially available, consumer available frameworks. They're just much more powerful and capable, even though they have guardrails, even though they have to know, obviously, they could potentially be monitored. So, what are these military and intelligence groups actually using it for? On Gemini, our AI system, we didn't see any of anybody bypassing systems to actually launch attacks or novel or unique abuse techniques. Lots of research, lots of other interesting things happening, and much like criminal groups, doing scripting and coding, taking out that kind of back room or preparatory part of the intelligence operation. The reconnaissance, the maintenance of software that could be offloaded to AI, and even the leading, most sophisticated offensive groups in the world, they're using AI to keep those people doing what they do best and kind of trying to take this other stuff off their plate. Iran being the heaviest actor, this is attributed Iranian groups. We know who it is. Over 30% of what we saw was related to, you know, either a little bit on researching known vulnerabilities, so just kind of preparing offensive work, but overwhelmingly research on their target and crafting phishing campaigns. So you can imagine, even though I'm sure they have many highly skilled linguists, they are relatively constrained to the languages they speak and the backgrounds that they have. Being able to pick out a new commercial or government target, especially outside of the Middle East, and in their own native language, being able to conduct research and get answers back, that's just a tremendous research advantage. I really expect AI to help Iran conduct more of those sophisticated reconnaissance and spearfishing campaigns outside of the places where they have a lot of linguistic and cultural experience. Israel, the Gulf, I think getting more into Europe and maybe even Asia and certainly the US is in the near future. China, as a country, obviously they're developing tremendous AI capabilities themselves, but they still, these government-backed groups, still seeking to use Gemini to conduct research. It's just a very useful research tool, and it's if you're asking about who works at a certain company or what fields are they in or where do they have offices or the kind of day-to-day business of a company, those are all queries you can run without tripping any of the guardrails. North Korea, they're consistently one of the most inventive actors when it comes to targeting the cloud. And so unsurprisingly, they're also some of the most forward-leaning on using Gemini and other LLMs to do actual payload development, malicious scripting. This is not writing the underlying exploit. This is kind of the scaffolding around it. How do I make sure that my payload deliverable in malware is going to avoid detection and doing very nuanced reconnaissance on their targets? Also, as we mentioned earlier, big generative AI users. I I included this photo just to show you on the left, obviously the base they were operating off of, and on the right, the converted photo they used for spearfishing. North Korea really invests heavily, particularly when targeting South Korea or the US. They invest heavily in social media based rapport building with their targets, having elaborate personas they can maintain over a long time, lots of pictures, lots of personal interaction, flawless kind of language to build trust and build trust and build trust and build trust over a long time. And then they attempt to deliver the malicious payload or convince the target to do something they shouldn't do, right? Often this is connected to those kind of software supply chain cases. But generative AI is really, turbocharging their ability to do those long-term rapport building virtual operations that are really more like traditional spycraft, but then enable a cyber operation. And just because I know there'll be interest, I'll mention we are tracking at least one case where malware itself taps into an AI system that we call this prompt flux. It does just-in-time modification. It makes a few Gemini calls. It appears to probably be financially motivated based on some of what we see behind the scenes in the malware. But so probably this is criminal. It's not necessarily that sophisticated. It's just an interesting example of someone using Gemini calls to modify a dropper. So, again, to avoid detection, not to necessarily develop a new zero day or do the kind of things that you see in movies, but change the software just enough to avoid signature-based detection. Well, that covers all the bad news for today. I hope you'll join me for another one of these CSA webinars. It's always a great environment, and hopefully, I'll get to cover some good news for you next time. Even though I'm a bad news expert, I appreciate your attention and being able to share some of what we've discovered at Google with you.